Hi viewers, welcome to Valarmathi'S classes. Already we have seen in detail about linear equations and solving linear equations. Now in this video we are going to see about linear inequalities and solving linear inequalities. First we can see what is an inequality. Okay, inequality is something opposite to an equation. It is something different from an equation. So when we are considering a normal equation, we will be having some expression on the left hand side and some expression on the right hand side, and we will be having an equal to sign in the middle. So the equation means that the expression on the left hand side, it is equal to the expression on the right hand side. So coming to an inequality, we will be having an expression on the left hand side, an expression on the right hand side, and in the middle will not be having a perfect equal to sign. Instead, we may have a less than symbol or greater than symbol or not equal to symbol or a less than or equal to symbol or a greater than or equal to symbol. Okay, so this is the main difference between an equation and an inequality. Okay, now these inequalities or relations without an equal to sign. Instead, we may have a less than symbol or a greater than symbol or less than or equal to symbol or a greater than or equal to symbol or a not equal to symbol, like that. Okay, now coming to these two words, already we have seen in detail about these terms in the previous videos itself. First term, it is solving. Solving means finding out the value of the variable present. So here, since it is inequality, so solving linear inequalities means finding out the value of the variable present in the given inequality. Okay, coming to this term, linear. Linear means if the degree of the given inequality is 1, then we can say that inequality as a linear inequality. So, solving linear inequalities means when a linear inequality is given, if we are asked to find out the value of the variable present in the given linear inequality, that is nothing but solving linear inequalities. Okay, so now we can start with an example. So here it is x less than 3. So here we are not having an equal to sign. So it is not an equation, it is an inequality. Okay, and we are having x on the left hand side and 3 on the right hand side. So the meaning for this inequality is the value of x can be any value less than 3. X cannot be equal to 3. Here since we are having a less than symbol. So the value of x may be some 2 or 1 or 0 or -1 or -2 or whatsoever it may be. It can be 2.99 also. That is also less than 3. So the value of x, it is less than 3. It is not equal to 3. So this is the meaning for this given inequality. We are saying this is an inequality because we are not having an equal to sign in the middle. We are having a less than sign. Now let us consider one more example. X is less than or equal to 3. So here in this case, we are having x in the left hand side, 3 on the right hand side, and we are having less than or equal to symbol. So here there are two sections. The first one is x is less than 3 and the next one is x is equal to 3. Less than or equal to. So x is less than 3, that is the first part, and x is equal to 3, that is the second part. So here when we are considering this inequality, the values for x can be 3 also because here we are having an equal to sign. So it can be 3 and all the other values less than 3 also comes within this relation. Okay. So here we are having an equal to sign. So even though we are having an equal to sign, we are calling it as an inequality because here we are having one more sign combined with this equal to sign. It is less than. So this sign implies that the values of x can be less than 3 also. So there we are not going to have a definite value for x. Okay, so this is also an inequality. So when we are considering both the relations, in the first relation, we will be having the value of x as all the values less than 3, and in the second relation, the values for x will be all the values less than 3 as well as the value of 3 also. So here 3 is included and here 3 is not included. Okay, so for better understanding, I'll explain these relations by drawing the number line representation. Okay, so now for the first relation, when we are drawing the number line, x is less than 3. So here it is 0, 1, 2, 3, 4, it will be going on. So 0 on the right hand side will be having all the positive values. On the left hand side will be having all the negative values. And this arrow mark denotes that it is a line. The values will be going on. No end. And also on the right hand side, the values will be going on. No end. And so we can represent the maximum value as some infinity. Here we will be having -1, -2, so etc. will be having maximum value of minus infinity. Okay, so now x is less than 3. So first, in order to bring out this relation in this number line form, first we have to see what is the value. So it is 3. So we can find out where we are having that value. So it is plus 3. So it is on the right hand side. So it is this point. So we have found out this value, and x is less than 3. It means x can take values less than this 3. So here we are having 3. So less than 3 means we will be having on the left hand side. So all the values on the left hand side becomes less than values for 3. So we may have any value in this range. So that is the meaning for this relation. So that is, we may have in this way. Here. Okay, now have this in mind. Now come to the next relation. It is x is less than or equal to 3. So here when we draw the number line, it is same. 1, 2, 3, etc. will be having infinity, -1, -2, -3, and minus infinity. Now here x, it is less than or equal to 3. So now in order to represent this here, first we have to find out what is the value. It is 3. So I am marking that value here. This 3, and x is less than or equal to 3. So the first point, it is x is less than 3. So we will be having all the values less than 3. So we will be having all the values on the left hand side of the number 3. So we will be having this section. Okay. Now x is equal to 3. So the value of 3, it is also included. Okay. Now this is the number line representation for x is less than 3, and this is a number line representation for x is less than or equal to 3. Now on seeing both the diagrams, both looks the same. There is no difference, but here there is a major difference, that is the value of x, it is not equal to 3. Here the value of x, it may be equal to 3 also. But that it is not shown anywhere here. Just we have started from that point of 3 and we have moved towards the left hand side. Here also we have done the same thing. Okay, so now in order to show these differences in the number line, we are having a simple concept, that is, when that particular value is not included, we have to use open circle there. This is an open circle. That is just a circle. That's all. So it is a open circle form. Open circle representation using open circle. When that particular value is also included, we have to denote as closed circles. Just we have to shade completely. So this is a closed circle. So closed circle. Okay. Okay. So now we are going to use open circles for the cases where that particular value is not included. We are going to use closed circles where we are going to include that particular value also for the value of the variable. Okay, that is, we can use open circles where we are having the signs less than or greater than in the relation. So these closed circles can be used when we are having less than or equal to or greater than or equal to signs, because here in the case of less than or equal to or greater than or equal to, that particular value also will be added, will be included. So there we can use closed circles. Okay, so this is the way of representing relations using number lines. Okay, so now here we should know one more way of representing the given inequality. So it will be very easy to solve the inequalities. What we are going to do is, we are going to write down the given relation or the given inequality in the form of an interval. So we will be having a lower value, we will be having upper value, and we will be using some type of bracket on either sides to show that it is an interval. Okay, so we will be having some value, comma, some value. So this will be the lower value, this will be the upper value or the maximum value, and we will be using any type of bracket. So here we are going to use two types of brackets. It may be this type of bracket or this type of bracket. So this is parenthesis and this is square bracket or bracket. So now we have to know when to use this parenthesis and when to use this bracket. Okay, so this parenthesis should be used when we are not going to include that particular value. For example, in this case, it is x is less than 3. So we are not going to include this value of 3. For such cases, we have to use parenthesis. So when a particular value is near this bracket, it is understood that from that value or till that value and not that value. That is the meaning. Okay. Now this bracket or the square bracket, it should be used when we are going to include that particular value. Okay. So I will explain with the help of these examples itself. So here it is x is less than 3. The value of 3 is not included. Okay. And here while writing the values, in the first place we have to write down the smaller value, that already I have said it is a lower value, and in the second place we have to write down the larger value. So coming to this example, so here it will be having first some value, comma, second some value. First it is a smaller value, second it is a larger value. So now here both the values are, one is it is less than 3. So in the left hand side, the smallest value, it is not specified, it is not mentioned. So we can consider this as the maximum lesser range. So it is minus infinity. So the first value is minus infinity. So and coming to the maximum value, it is this 3. Here this is the lesser value, this is the maximum value. Already we know that. So when we are moving towards the right hand side, the values will be going on increasing. So now this is the maximum value compared to these two values. Okay, so that should be written on the right hand side. So that is the upper value or the maximum value. So minus infinity, comma 3. Now here minus infinity, that it is also not included. We don't know anything about the value, about the range. So here we have to use a parenthesis. It is not included. And coming to this value, it is 3. This 3, it is also not included. So when a particular value is not included, we have to use parenthesis. So now the interval notation for this relation is minus infinity, comma 3. When we are seeing a bracket in this way, that is a parenthesis in this way, automatically we can come to a conclusion that that particular value is not included. Just it is the value of some limit. It shows the range, that's all, but that particular value is not included. Okay, now coming to the next example. Here it is x is less than or equal to 3. So less than, so the lower value it is minus infinity. So comma, coming to the right hand side, here it is 3. So 3, that value is also included. So in order to show that it is included, we have to use a square bracket. So here it becomes again bracket. So here anything is not mentioned about this minus infinity. So we cannot say that that particular value is included. Just we have written the range, that's all. So here we have used a parenthesis. Similarly here also we have used a parenthesis. Coming to the right side, here it is 3. That particular value is included because it is less than or equal to 3. So we have included that value. So in order to show that, I have used a bracket or a square bracket. So now in this way we can differentiate whether the particular value is included or not included. So when it is included, we have to use this type of bracket or the square bracket, and when it is not included, we have to use parenthesis. Now we can bring out this interval notation from this given inequality also. That is x is less than 3. Less than 3 means this will be the maximum value. So it is 3, and in the first place we will be having the x is less than 3. So what will be the least value? So we can use minus infinity there. So here also it is not specific, so we can use a parenthesis. Here it is less than, so that particular value is not included, so we can use a parenthesis. So now coming to the second example, x is less than or equal to 3. So similarly here less than 3. So on the right hand side we will be having 3 for the upper value, and for the lower value, since it is less than 3, no particular value is given on the left side. So we can use minus infinity, and it is also not specific. So I am using parenthesis. Here it is 3. That particular value is also included. So we can use a square bracket or a bracket. Okay, so now, directly we can bring out these interval notations by analyzing the given linear inequality also. Okay, now here one more thing is to be known. It is, so on seeing the first relation x is less than 3, here the meaning for this relation is the values of x are all the values less than 3. It is not equal to 3. So there is no possibility for x equal to 3. It is a strict inequality. There is no possibility for an equal to sign there, or there is no possibility for an equality there. So these types of relations, they are called strict inequalities. Coming to the second example, here since we are having an equal to sign, there is possibility for the value of x equal to 3 also. So even though it is an inequality, it is not a strict inequality because there is a possibility for x is equal to 3. Okay, so here this relation or inequality, it is example for a strict inequality. There is no chance for a equality there. Here there is a chance for the value of x is equal to 3. So it is not a strict inequality. Not a strict inequality. Okay, so now let us see one more example. X is greater than or equal to 3. So here on analyzing this inequality, x may have values greater than 3 or equal to 3. Okay, so on drawing the number line for this relation, -1, -2, -3. So here it is minus infinity, here it is plus infinity, greater than or equal to 3. So we have to first find out the point 3. So greater than 3 means we will be having all the values above 3. So we will be having all the values to the right hand side of 3. So we will be having this section. Okay. And yes, it is equal to 3 also. So that particular value is also included. So it may be equal to 3 or any value greater than 3. That is the meaning. Okay, so now in order to show that particular value is included, we have to use closed circles there. So now this is the number line representation for this inequality. Okay, now we can write down the interval form also for this. So now x is greater than or equal to 3. So we will be having 3 as a lower value and infinity as the maximum value. Okay, so 3 as the lower value and infinity as the maximum value. Now we have to see what type of bracket should be used here. So here since 3 is included and we are having 3 here, what we have to do is we have to use square bracket or bracket near that number. So it is this bracket. Okay. Now coming to the next part, it is infinity. So there it is not specified. So we can use this type of bracket. So it is understood that lower value it is 3, upper value it is infinity. So all the values above 3 will be having for, we may have for x, and since that particular value is included, here we are using a bracket or a square bracket. Okay, now coming to this relation, since we are having an equal to sign here, it is not a strict inequality. Okay, so now having all these points in mind, we can come to the main topic. It is solving linear inequalities. Now let us consider this example. 2 is less than 3. Now if I am going to interchange the position of both the numbers, that is if I am going to bring 3 to the left hand side and 2 to the right hand side, actually what I have to do here, 3 it is greater than 2. So the symbol it is in this way. Here we are having the greater side and here it is the lesser side. Now I have brought the 3 to the left hand side. So now what I have to do? I have to change this sign also. I have to make it as this sign. That is, here it is less than symbol, here it is greater than symbol, because here since this 3 I have taken here, this 3 it is greater than 2. So in order to bring the true concept here, I have brought out a change in the sign of inequality. Okay, so now this is a very important thing to be noted. So now if we are having x in the left hand side and y in the right hand side, and if it is in this way, if I am going to bring this y to the left hand side and this x to the right hand side, I have to change the sign of this inequality. I have to change the sign of this inequality. I have to change this less than symbol to greater than symbol, since y it is greater than x. So it becomes y greater than x. Now both are going to give the same meaning. X it is less than y. So if x is less than y will be greater than x only. Okay, so both will convey or give the same meaning. So this is a very important concept to be noted in the case of solving linear inequalities. Okay, now if we are having two inequalities, we can see what we have to do. That is, if it is given in this way, some x is less than y and y is less than z, then we can combine these two inequalities as, so here it is less than symbol, here also it is less than symbol. So x it is less than y and that y it is less than z. So now this can be written as x is less than y, this y is less than z. So this y is less than z. So we can combine in this way. So x is less than y, less than z. It means that x is less than y is less than z, and also x is less than z. So we can take in any way. Okay. So now let us consider this relation x is less than y. So now we can see what happens when we are going to add the same value to the left hand side of the relation as well as to the right hand side of the relation. And we can see what happens when we subtract the same value from both the sides of the given relation or inequality. So we can analyze all these things. Okay, so now before going into this topic, let us consider this diagram. So I have drawn roughly the diagram similar to a weighing balance. So all these things, they are wooden blocks. All the blocks are of same type. So here I have placed 5 blocks and here I have placed 3 blocks. So here since the number of blocks is more, the weight also will be more, and so here this balance is tilted towards the left. Okay, so now if I am going to add one block to this side as well as one block to this side, what happens? the balance will be in the same state. There will be no change in the state of the balance, because since same number of block is added to both the sides, the weight difference will be the same. So the position or the nature of the balance will be the same. If I am going to remove one block from both the sides, what happens? Again, the position of the balance will be same. If I am going to remove two blocks from both the sides, again the nature of the balance will be same. Okay. So this is because when I am adding the same value to both the sides, or when I am removing the same value from both the sides, what happens? There is going to be no change in the difference of weights. Okay, that is the reason. That is already what difference will be maintained, that will be maintained after doing all these alterations also. So that is the main reason here. That is, here the number of blocks was more. Initially compared to this, I added the same number of blocks to both the sides. There was no change in the state of the balance. I took out some blocks from both the sides. That is same number of blocks from both the sides. There was no change in the state of the balance. This is because when we are adding or subtracting the same value, what happens? The already existing difference will be existing as such. That is the main reason. That is, here it is similar to this. The weight it is greater than this side. Okay. Just have this concept in mind and relate that to this. Okay. So now here x is less than y. So when I am going to add a particular value to the left hand side, and if I am going to add the same value to the right hand side, what happens? There will be no change in this sign of inequality. When I am going to subtract a value from the left hand side, and if I am subtracting the same value from the right hand side also, what happens? There will be no change in the sign of inequality. That is, when we are adding, that is, if I am adding some value a to the left hand side, and if I am going to add the same value to the right hand side, here the sign of inequality, it will be as such. There will be no change in the sign of inequality. And coming to subtraction, if I am going to subtract a value of a from the left hand side, and if I am going to subtract the same value from the right hand side, there will be no change in the sign of inequality. Okay, now coming to multiplication, we have to be careful about the sign of the number what we are going to multiply. That is, for example, if you are having x is less than y, if I am going to multiply this x by 2, and if I am going to multiply this y also by 2, what happens? I am multiplying the same value on both the sides. So there is going to be no change in the sign of inequality. But if I am going to multiply a negative value, for example, if I am going to multiply this left hand side by some minus 1 and right hand side by minus 1, what happens here? It becomes minus y x. Here it becomes minus y, and we have to see what happens to the sign. Okay, now before this, just consider this example 2 and 3. 2 it is less than 3. What about minus 2 and minus 3? Minus 2, it is greater than minus 3. In our number line, here it is 0, 1, 2. Here it is minus 1, minus 2. So, here when we are moving from left to right, the values are going on increasing. Here minus 2 it is here and minus 3 it is here. Minus 2 it comes to the right hand side of minus 3. So, minus 2 it is greater than minus 3. Minus 2 it is greater than minus 3. This is one way of analyzing. Or now here we are having 2, it is 3. 2 it is less than 3. This is a smaller number compared to this. When I am going to insert minus signs to both the numbers, what happens? Minus a smaller value. Here it is minus a bigger value compared to this. So this will be very much negative compared to this. So this will be greater than this. So what happens? The sign of inequality has changed. Okay, so now minus 2 it is greater than minus 3. That is, when we are having x less than y, if I am going to insert a minus sign on both the sides, what happens? Automatically I have to change the sign of inequality. Inserting this minus sign is nothing but multiplying both the sides by minus 1. That is x into minus 1 is equal to minus x. Y into minus 1 is equal to minus y. That is when I am multiplying minus 1 to both the sides of the inequality, we have to change the sign of inequality also. That is the sign of inequality also changes. Okay, so it is not only for minus 1. When we multiply any negative number to both the sides of the given inequality, automatically we have to change the sign of inequality. So now here I have multiplied a positive number 2. So the inequality remains as such. There is no problem. So now if I am going to multiply minus 1 to both the sides, what happens? It becomes minus x minus y, and the sign of inequality, it was less than. So now here it becomes greater than. Okay, now if it is in this way, if I am going to multiply by minus 2 on both the sides, what happens? It becomes minus 2x. Here also it becomes minus 2y. So since we are multiplying by a negative number, automatically we have to change the sign of inequality. So these are some concepts to be had in mind. That is, when we add a same number to both the sides, the inequality doesn't change. The sign of inequality doesn't change. When we subtract the same number from both the sides, the sign doesn't change. It will be as such. Okay. When we multiply a positive number to both the sides, the inequality doesn't change. The sign of inequality remains as such. When we multiply a negative number, what happens? The inequality or the sign of inequality changes. Okay, now let us consider one more example. xy. Okay, so before this, let us consider 2, it is less than 3. What happens when we take the reciprocal of this number? 2 is less than 3. When we take the reciprocal of this 2, it becomes 1 by 2. Here also I am taking the reciprocal, it becomes 1 by 3. So 1 by 2, it is greater than 1 by 3. We are dividing one whole part by 2. Here we are dividing by 3. So here the value will be less compared to this. So it means that here we will be having the lesser side. So it should be in this way. So now what happens? The sign of inequality has changed. That is, when we take the reciprocal of both the numbers, what happens? The sign of inequality changes. So here if it is x and here it is y, if you are having this less than sign, if you take the reciprocal as 1 by x and 1 by y, it becomes 1 by x is greater than 1 by y. Okay. So now let us consider this relation x is less than y. We can see what happens when we divide both the sides by the same number. Okay, so now if I am going to divide the left hand side by 2 and the right hand side by 2, what happens? Already the value of x, it is less than y. So when I am dividing x by 2 and y by 2, what happens? This value will be definitely less than this value. That's all. There will be no change in the sign of inequality. But if I am going to divide by a negative number, again it will be similar to our multiplication. That is, the sign of inequality will get changed. So x, if I am going to divide by minus 2 and if I am going to divide y by minus 2, it becomes minus x by 2 and minus y by 2. So what happens? X is less than y. So x I am going to divide by 2, y I am going to divide by 2. So x by 2 and y by 2, if I am considering, x by 2 will be less than y by 2. So if I am inserting a minus in front, what happens? Automatically the sign will get changed. So automatically it will become in this way. So when I am going to divide both the sides of the inequality by a negative number, the sign of inequality will get changed. If I am dividing by a positive number, the sign of inequality will remain the same. Okay, now let us consider these examples. So, let us consider this first example. X plus 1 is less than 5. And if we are asked to solve this inequality, so that is we are asked to solve x plus 1 less than 5. That means we are asked to find out the value of x, since x is a variable present in this inequality. Okay, so we have to do something to find out the value of x. Okay, so we can see what we have to do. So x, it is in the left hand side and we are having plus 1 here. So now we have to do something to remove this 1 so that we'll be having x alone here. So what we can do, if we are inserting a minus 1 here, it becomes plus 1 minus 1. So it gets cancelled and so we'll be having x alone. But we cannot do these operations. We cannot insert any operation on one side of the relation or inequality. So if we are going to do, we have to do on both the sides. So now what I am going to do is, on the left hand side, x plus 1, it is already present. I am going to insert a minus 1 to that. So now here it is 5. So here I have inserted minus 1. So I have to insert the same thing to the right hand side also. 5 minus 1. So now what happens to the sign? I have subtracted both the sides. 1, that's all. So when we are subtracting, the sign of inequality doesn't change. Already we have seen. So here we will be having the same sign. Okay. So now in the next step, x plus 1 minus 1. So it is x, because plus 1 minus 1, it becomes 0. So we will be having x less than 5 minus 1, it is 4. Okay. So x is less than 4. So now how to find out the values? Already we have seen. So x is less than 4. So the values will be all the values less than 4 but not 4. So the lesser value will be minus infinity. Already we have seen. For x less than 4, the number line will be in this way. 0. So 1, 2, 3, 4. So less than 4 means we will be having this section. So here it is minus infinity. So this value it is not going to be included. So here we have to use a open circle. So this is a number line representation. So writing in the interval form, so it becomes minus infinity, comma, what about the final value? It is 4. But we are not going to include this 4 because here we are having a less than sign alone. So we have to use a parenthesis. It means that this value it is not going to be included. Just this is the higher range, that's all. So here, since it is minus infinity, here we are going to use parenthesis. Okay, so now it is minus infinity, comma 4. So this is the interval notation for the value of x. So the lower value it is minus infinity and the upper it is 4. So it can be any value between these values. Okay. So x can have any values between these two values. Okay, now coming to the next example, it is x plus 1 less than 2x plus 2. So here it is plus 1, here it is plus 2 and here also we are having a x term. So what we have to do, we have to take this term to the left hand side. So that we will be having the variable x in the left hand side. So here it is x. So this 2x when we are bringing to the other side, here it is plus 2x. So it becomes minus 2x. This is similar to what we have done in the previous cases and all while solving linear equations. The same thing. So x, this plus 2x when it comes to the other side, it becomes minus 2x. And the next here it is 2. When this plus 1 comes to the other side, it becomes minus 1. So it is in this way. Okay, now x minus 2x. So it is minus x. That is minus 1x. So it is minus x. So less than 2 minus 1, it is 1. Okay, so minus x is less than 1. So now we need the value of x. So what we have to do? We have to take out this minus. So to take out this minus, we can multiply this side by minus 1. So it becomes minus x into minus 1, it will be equal to x. So when we are doing some operation on the left hand side, we have to do the same thing on the right hand side also. So minus x into minus 1 and in the right hand side it becomes 1 into minus 1. Okay, so now I have multiplied both the sides by a negative number. So what happens to the sign of inequality? It changes. So here the sign becomes greater than. So now minus 6 into minus 1, it is x. So now x will be greater than 1 into minus 1, so it is minus 1. So now we have to find out the values. So now on drawing the number line, here we will be having 0, minus 1. So here it is 1. So greater than, here we will be having infinity. So greater than minus 1. So here we are having minus 1. So since it is greater than minus 1, we will be having on the right hand side of minus 1. So it will be this section. Okay, so now here since it is greater than sign, this value is not going to be included. So we can use open circle. Okay, so now on writing the interval notation, so here it is greater than minus 1. So here the lower value it is minus 1 and the greater value it is infinity, and here since it is infinity we can use parenthesis, and here this value is not included, so it becomes parenthesis. So this is the interval notation for the values of x. Okay. Now coming to the third example, it is 2 into x plus 1 minus 3 is less than 4x plus 3. So here we are having a bracket. So what we can do is we can expand the terms first. So it becomes 2 into x. So it is 2x. Then plus 2 into 1. So it is 2. Then minus 3 is less than 4x plus 3. So now 2x, so now plus 2 minus 3. So it becomes minus 1. The difference it is 1, greater number has negative sign, so it becomes minus 1. And the next less than 4x plus 3. Okay, now here we are having 2x, here it is 4x. So we can take this 4x to the left hand side, so that we will be having all the variables on one side. So here it is 2x, when that 4x comes to the other side, it becomes minus 4x. Then less than, here it is 3. When this minus 1 comes to the other side, it becomes plus 1. Okay, now it is 2x minus 4x. So 2 minus 4. So it is minus 2. So minus 2x, it is less than 3 plus 1, it is 4. Okay, now we have to find out x. Here it is minus 2 into x. So now in order to have x alone here, we can divide this whole part by minus 2. So we will get x alone. So I am going to divide both the sides by minus 2. So here it is minus 2x by minus 2. Here it is 4 by minus 2. Since I am dividing by minus 2, what happens to the sign of inequality? It gets changed. So it becomes greater than. So now here we can cancel both the numbers. So we will be having x greater than 4 by minus 2. So it is minus 2. So x is greater than minus 2. So when we are drawing the number line, here we will be having 0, 1, here minus 1, minus 2, minus infinity. Here it is infinity. X is greater than minus 2. Here it is minus 2. So greater than minus 2. So we will be having this section. Okay, now since it is greater than, this value is not included. We are not having any equal to sign here. So in order to show that, we can use open circle. Okay, so now on writing this in the interval notation, minus 2 it will be the lower value, greater value it will be infinity, and the next here since it is infinity we can use parenthesis. Here also since this value is not included, you can use parenthesis. Now let us consider this example. So here we have 20 is greater than 5x is greater than 10. So we are asked to solve this linear inequality. We are having two signs of inequality. So we have to find out the value of x, that is a variable. So we can do, so we can see how to do it. Okay, so now here this x, it is present in the center expression. So and x it is present along with this 5. That is 5 it is multiplied with x. So we can we have to do something and bring out x alone here, so that we can find out the lower as well as higher values for x. Okay, so now we can see how to bring out x alone here. So here we have 5 into x. So when we are removing this 5 from this expression, it becomes x. So 5 can be removed by dividing this term by 5. So here I am going to divide by 5. So now when we are having a relation or inequality in this form, we cannot do an operation to a single expression. We have to do that to all the expressions present in the relation. So what I am going to do is, I am going to do the same to both the other terms. So I am going to divide by 5. So now here it is greater than, here it is greater than. I am dividing by a positive number only. So what happens to the sign of inequality? It doesn't change since it is a positive number. So the inequality, it remains as such. Okay, now 20 by 5. So it is 4 greater than 5x by 5. So it is x greater than 10 divided by 5. So it is 2. So now the value of x is just between 2 and 4. Here also it is greater than sign. Here also it is greater than sign. That means the value, it is not equal to 4 as well as it is not equal to 2. But it is between these two numbers. So now we have to write down the interval notation. So the interval notation is the first value. So here now, here it is 2, here it is 4. This is a lesser value, this is a greater value. So I have to write this first, 2. And the next comma, this is the greater value. This is also not included. Here it is greater than sign alone. So this number is also not included. So near that number I have to use parenthesis. Here it is greater than sign, greater than sign. This number is also not included. So here also I have to use parenthesis. Okay. So now we have obtained the interval notation. If you are finding any difficulty to write directly, here it is a greater number, here it is a smaller number, what can be done is you can change this inequality as first you can write down the smaller number x, then 4 greater number, but here it is x is greater than 2. Here we are having x, here it is 2. So x should be greater than 2. So we have to change the sign of inequality. And here it is x is less than 4. So x it is less than 4. So in this way we can change and then we can write down, or we can write directly by using this relation itself. We can go by any way. Okay. So now, so this is the answer. This is the interval notation. So now if we are asked to draw the number line representation 0. So here it is 1, 2, 3, 4, 5, etc. Here it will be infinity, and 2 and 4. So here we are having 2, here it is 4. So between these two values, so this is the range, but 2 it is also not included and 4 is also not included. So we will be having open circles for both the values. Okay, now the next problem. So it is 20 is greater than or equal to 5x is greater than or equal to 10. So now here the same thing, here I have inserted an equal to sign, that's all. Okay, so the same thing as before. Here we are having 5x in the middle. So in order to bring x alone here, we can divide this term by 5. So it becomes 5x by 5. So here also we have to divide by 5. So here also we have to divide by 5. And here it is greater than or equal to. Here also it is greater than or equal to. Now the next thing, 20 by 5. So it is 4. So here it is greater than or equal to. So here it is x greater than or equal to 10 by 5. So it is 2. So we will be getting the same way as before, but we are having an equal to sign also. Now we have to bring out the answer. So now here 2 it is a lesser value, 4 is a greater value. So first we can write down 2, comma we can write down the greater value. 2 is also included. So here we are having an equal to sign. So near 2 we have to use a square bracket or a bracket. Now here 4 is also included. X is equal to 4 also. It may be equal to 4 also. So near 4 we have to use a bracket or a square bracket. So now this is the interval notation. So now here when we are drawing the number line forms 0, 1, 2, 3, 4. Here it is infinity. So here 2, 4. So 2 it is 1.4, it is 1. Both are included. So here we have to use closed circle. Here also we have to use closed circle. And here this will be the representation. Here also, here this will be the representation. Okay. So now in this way we can bring out the answer. Okay. Okay, now coming to the next example, it is 12 less than 2x plus 4 less than or equal to 20. So now here we are having x in the middle term. So here it is 2x plus 4. So what we have to do is first we have to bring out the value of x. But there is a value of 4 added to 2x. So before removing this 4, we cannot take out this 2. So first step is we have to remove that 4. So here it is plus 4. So in order to remove that 4, we can insert a minus 4 there. So we cannot insert to a single expression. So that should be done to all the 3. So it becomes 12 minus 4. Here in the middle term it becomes 2x plus 4 minus 4. And here it becomes 20 minus 4. Now here it is less than. I have subtracted 4 from all the terms. So the sign of inequality doesn't change. So it becomes the same. So here it is less than or equal to. Now 12 minus 4 it is 8 less than 2x plus 4 minus 4. So it is 2x plus 4 minus 4 it is 0. So it becomes 2x. Now less than or equal to 20 minus 4. So it is 16. Now the next step, here we are having 2x. We need x alone. So what we have to do? We have to divide this by 2. So that 2 and 2 will get cancelled and we will be having x alone. So we cannot do for this single term. We have to do for all the 3 terms. So I am going to divide by 2. So here it is 2x by 2. So here it is 16 by 2. Now I have divided all the terms by 2, that is by plus 2 only. It is a positive number. So the sign of inequality doesn't change. So it becomes the same. It is in this way. So now a by 2 it is 4. So less than 2x by 2 it is x. Less than or equal to 16 by 2 it is 8. Now the interval notation is, so the 4 is the lesser value, 8 is the higher value. So 4 comma 8. And so now 4 it is less than x. That is x is greater than 4. Here we are not having any equal to sign. That means 4 is not included. So here we have to use parenthesis. Now here it is 8. Here we are having less than or equal to sign. That means this 8 is also included. So here we have to use square bracket or bracket. Okay, so now this is the interval notation. Okay, now on drawing the number line, here it is 0, 1, 2, 3, 4, 5, 6, 7, 8. Infinity. Minus infinity. So here 4 comma 8. So 4 is one point and 8 is the other point. 4 it is not included. 8 it is included. So here we will be having closed circles. Here we will be having open circles and this is the range. So now in this way we can represent using the number line method. So this is itself enough. If needed, we can use this. So in this way, we can solve linear inequalities. So thanks for watching this video. We'll see the continuation in the next video.